Hi guys, my name is Peter C. Double Jr., math instructor at the University of Liberia and your tutorial teacher. In my today's video, I will be looking at solving differential equations. Particularly, we'll be discussing eliminating arbitrary constants. So in previous lectures, I discussed a few other problems involved eliminating arbitrary constants. So we want to do additional 3 more problems, question 4, 5, and 6. So let's see how we can do that. Now, the problem says we must eliminate the arbitrary constants to obtain the differential equation. So to do that, we must first observe within the problem how many constants do we have. If we have one constant, it means the differential equation will be a first order differential equation. That is, we must differentiate once. If we have 2 constants, it means that we must differentiate twice, because the differential equation will be a second order differential equation. So the number of constants determines the number of times you have to differentiate. So the first problem says y equals, let's say y times sine of x minus xy equals to c. Since we have one constant, it means that this is a first order differential equation. So we can just multiply y by sine. So it's y sine of x minus x y squared equals to c. So we can now differentiate. In this first term, you have two factors. So we must use the product rule. We hold y and differentiate sine of x, we get cos of x. Plus we hold sine of x now and differentiate y. The derivative of y is 1. But because we have differentiated with respect to y, we have differentiated the function y. Therefore, we have to attach y prime. So we have minus, we put this one in bracket because of the negative sign. So again, we use the product rule because there are 2 functions here being multiplied by each other, a linear function and a quadratic function. So we hold x and differentiate y squared. So it's 2y. Since we have differentiated y, which is the name of the function, we must attach y prime. So we have plus, we hold y squared now and differentiate x, we get 1. Equals the derivative of a constant, is just equals to 0. Now we can simplify now because we have already gotten rid of the arbitrary constant. There's no constant in the problem. So we just need to simplify now and write our differential equation in the form and manner in which we want it to be written. So we have y cos of x plus sine of x y prime minus 2x y prime minus y squared equals to 0. So we can decide to group all of the terms with y prime, in fact. So y prime minus 2x y prime. And then we send the remaining terms across the equal sign. If wish, we can maintain it on one side, whatever way. So even if we maintain it, we will have plus. So let's send it on the other side because we want to like factor out y prime and divide both sides and everything. So let's send it on one side. So if we send it one side of the equation, we have y squared. This goes across as well. You have y cos of x. So y prime factor out, you have sine of x. Now the angle here is x. The angle is not xy. So we can move y, but we cannot move x. So take note of that. So y comes across, you have minus 2x y equals, now we can factor out y to further simplify this, is just y minus cos of x. So we divide both sides now by sine of x minus 2xy, sine of x minus 2xy. So this cancel this. You have y prime to be equals to y times y minus cos of x all over sine of x minus 2xy. So this is a differential equation. Or you can rewrite it as dy by dx, thereby changing this y prime to dy by dx. equals y times y minus cos of x all over sine of x minus 2xy. You can also decide to multiply, to get rid of this dy, let's say dx, you can multiply this entire expression by dx. So if you do that, you have dy now to just be equal to y times y minus cos of x all over sine of x minus 2xy times dx. You can also decide to send this entire term across the equal sign. So if you send that entire term across the equal sign, you will have dy minus y minus cos of x all over sine of x minus 2xy times dx is equals to 0. So whatever way you can write it is still the same. Remember, you already have your differential equation, so it's just about rewriting the differential equation. So move to the next one. Now in this problem, we have two constants. So it means that there are two, let's say we must differentiate two times. There is a second order differential equation. So we take the first one, y prime equals ax is just a. This is a constant, equals to 0. And then we have y prime prime, which is just equals to 0. So there's the differential equation y prime prime equals to 0. Or you say the 2y all over the x squared equals to 0. So other ways you want to write it. We'll move to the next one. This has one constant, so we must differentiate once. So we can simplify this thing by saying cx squared, or you just leave it like this and differentiate. Since c is already one side of the equation, you can just differentiate using the quotient rule. So we hold x squared, we differentiate y, we get y prime, minus we hold y, we differentiate x, we get x squared, we get 2x, all divided by x squared all square according to the quotient rule, and then this equal to 0. So we further simplify, you have x squared y prime minus y times 2x, which is just 2xy, divided by x to the fourth power equals to 0. So what can we do? We can factor out y prime. Let's say we can factor out x to the first power, or we can say each term expressed over x to the fourth. So we have 2xy x to the fourth equals to 0. So this will reduce 1 from here, or that's a 2 from here. You will have y prime now all over x squared minus 2y all over x to the third power equals to 0. So if we like, we can make just the y prime to be standing alone. So if we send this second term across, we will have y prime over x squared equals 2y all over x cubed. So we can multiply the whole thing by x squared. So we have this x squared going out, y prime equals, then this and this, you will take 2 from in this 3, you just have 2y all over x. So this is the differential equation. Or we can say dy by dx is equals to 2y over x, right? We can also say let's multiply this whole thing by dx, therefore having dy is equals to 2y dx, or that's a 2y over x, then dx. You can even send it on the left hand side of the equation, whatever way you want to do it. So this is how we eliminate arbitrary constants, and it's very, very easy. No stress in it. Very, very easy. So watch out for the next set of examples. You will see other forms of problems that we can, you know, use other methods or apply other tricks to be able to easily find the differential equations of those problems. So thanks so much for watching. Please don't forget to subscribe to our channel. Thank you. See you in our next video.